Alright, you want to learn some new words I learned today?
Yeah, whatever, Brian.
I learned derivative, velocity, acceleration, and calculus. I wonder if I could eat that for lunch.
Probably not, but those are all good parts of math.
What kind of math?
Well, it's interesting because we're driving right now, and as we're driving, our position's changing. And if you take the derivative of your position, you get your velocity. If you take the derivative of that, you get your acceleration. If you want to pull over here in the dirt, I can show you how it works.
Seriously?
Mm-hmm. Is the graph of our position function, or in our case, the distance we've traveled. X-axis, Y-axis. Now, as we start going in the car, we're traveling at a slower pace. So our distance at first is not changing very much, but as we go faster, our distance changes at a faster rate. So we'll see the line start out fairly slow and increase as time goes on. Now, the derivative of that, or the slope of the line at any given point, is our velocity graph. Now, in our velocity graph, we use v, x, and y yet again. Our velocity will increase until we attain whatever speed we maintain throughout the rest of the drive, at which point our velocity will tend to flatten. So for the graph of the acceleration, we'll use a, and yet again, x in our y-axis. Now in our acceleration graph, at first, the acceleration will be greater as the car goes up to about 10 to 20 miles per hour and then slowly gains more and more speed. So we'll end up with something with a high acceleration at first, which slowly gets lower and lower. All right, now that we understand the basic principles, let's try a harder problem. So for this, take this as the position function of the problem as the point moves across the linear plane. So to take the derivative of this to get our velocity at, say, velocity equals 2 and the acceleration also equaling 2, first we'll take the derivative and then plug in 2. So we will do y prime equals 15 t squared plus 3. Now plugging in 2, we get y prime equals 15 2 squared plus 3. 2 squared is 4 times 15 plus 3, 63. Now, if we go on to take the derivative of y prime to get the acceleration, we get y double prime equals 30t. So for this, we get y double prime, plugging in 2 for t, equals 60. That means that at a time of 2, our velocity is 63, and that at a time of 2, our acceleration is 6. In a second, we will be 16 meters away.